So we got a calculator question here. It's particle motion again. And I'm hoping that you guys have found that a lot of these particle motion ones are very similar. And so first question it asks us is, when is the speed of the particle 2? So we're looking for all values between 2 and 4, inclusive of 2 and 4, for which the speed of the particle is 2. So we will remember that the speed of a particle is the absolute value of the velocity. And so all you need to do is just graph the absolute value of the velocity and graph y equals 2 and see where they intersect. And you would find that happens on that interval at 2 different places that you would round to 3 decimals or more, 3.128 and 3.473. Is that straightforward enough or no?
Yeah.
Cool. You got 1 point for, well, we'll say basically one. Yeah, I said basically 1 point for looking at absolute value of v is equal to 2. So you should really write. I should write this up here. You should write absolute value of v of t equals 2, and then just graph both of those, and then so that's 1 point, and then 1 point for this. Okay. Second part B here, is write an expression involving an integral that gives the position s of t. So we just want an expression that gives the position, and then we want to use that to find the position at 5. And so our expression should be s of t is equal to the initial position, which is 10, and it's 10 at 0. So when we integrate, we got to integrate from 0 to whatever t value we're looking for. So -2 plus t squared plus 3t to the 6/5 minus t cubed dt. So that's your expression. And yeah, actually I probably should have written these as x's or some other variable, since I put a t up there, so I'm going to do that. But it's you always got to change this variable to it. We talked about this before. It's called a dummy variable. So 10 plus the integral from 0 to 2 or 0 to t of v of x. And then just evaluating that at 5 means you just plug in 5 and evaluate that integral. So you could say that s of 5 was -9.207. And 1 point for this expression, 1 point for this answer. And so just make sure that you always remember the initial condition has to be included there. And if this said that the position at s of 1 was equal to 10, well then you still put 10 plus, but your integral, instead of going from 0 to t, would go from 1 to t, because the x value that you needed there, or the t value that you needed, was 1 instead of 0. Does that make sense, everyone?
Why aren't you using the absolute value of v of t for part B?
Because this is talking about a position and not a distance traveled. Position comes from an integral of velocity, that's displacement, so it tells you how far you've moved left or right from your initial position, whereas in relation to where you started. But absolute value tells you the total distance that you traveled, right? So displacement tells me, okay, I started here, I went to here and back to here. My displacement is this. My total distance traveled is all of this plus this. That's the absolute value of velocity's integral. That's the total distance traveled. But the displacement, which tells you a position, is just the integral of the velocity, not the speed. Does that make sense?
Yeah.
Mm-hmm. All right. Part C wants us to find all of the times on this interval from 0 to 5 where the particle changes direction. So if it changes direction, you can only do that potentially if the velocity is 0, or if it was undefined, but none of these places is it undefined. because if you look at that function, it's never undefined. So we will just set v of t equal to 0. And you will find two different values where that occurs on that interval. One of them is 0.536. And the other one is 3.318. And you would look at your graph of the velocity, and you would see that the velocity goes from positive to negative. Well, actually, it goes from negative to positive at 0.536. And it goes from positive to negative at the other value at 3.318. And so we know that's where it changes direction, because the velocity went from negative moving left to positive moving right, and then went from positive moving right to negative moving left. And you got to make sure that it actually changes those signs. You could just see that by looking at the graph of velocity, but velocity could equal 0 and then just bounce off the x-axis, in which case you would not have a change in direction, right? The velocity was positive, 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 0. So it slowed down, stopped, but never went the other direction and then continued on to the right. Does that make sense?
So could a sign graph just be the proof as well?
Yeah, just make sure if you do a sign chart here, like you put those values on, that when you do that, make sure you say that this is a sign chart for v of t, right? So that you can say that, your velocity was negative and your velocity was positive and your velocity was negative. And then just like in there, right, moving left, right, left, just to make sure that you're being as clear as possible.
So is College Board really this picky about what they want, or is this to like ensure that we just don't get any stupid points taken off?
This is to ensure that you don't get any stupid points. If you wrote just this, you're probably good. I mean, this is all they wrote in their scoring guide. But if you this is not in their scoring guide, so if you just put this, I would say 99% of the graders will give you the points for this. But I can't promise that you don't have somebody that's there on the last day of testing that's pissed off that they want to go home and they just got in a fight with their husband or wife or something and wants to get out of there and is angry. And so they're just marking people down left and right. It's not graded by a computer, it's graded by a person. And people have thoughts and feelings and do things. Just to be really careful. I always ensure that you get the points. That's, yeah. Does that answer your question?
Yeah.
Okay, good. Oh, sorry, and that was worth 3. Where did that go? That was worth 3 points. 1 point was for just doing this, and then 2 points was for all of your answers here with whatever justification you've got. Okay, then part D said, is the speed of the particle increasing or decreasing at t equals 4? And so to find out if the speed is increasing or decreasing, once again, we have to look at the sign of the velocity and the sign of the acceleration. So v of 4 came out to be negative 11 point something, negative 11.475 something. And a of 4, which is v prime of 4, which since you have the function v, you'll just use your calculator to evaluate the derivative of v at 4. That came out to be negative 22.29 something or another. And so you'd note that this is less than 0 and this is less than 0. And you'd say speed is increasing. And you would want to note because a of 4 and v of 4 have the same sign. Good or no? Any questions on that question at all? Oh, and 1 point there for what?
I was just going to ask for the point breakdown, which we were about to do.
Yeah, so 1 point for getting the value of these two things and 1 point for this. Any other questions on that? All right. Next one. This one was a non-calculator one. That's exciting. So first thing it asked you, they give you a velocity again. And the first thing they asked you about is when is the particle moving to the left for t equals 0 to t equals 12. So for the particle to be moving to the left, that would mean that velocity has to be less than 0. And so we would figure out first when does v of t equal 0. So that would be when does the cosine of pi over 6t equal 0. And cosine equals 0 whenever the angle pi over 6t is equal to what? What values of cosine give you 0? Pi over 2, right? Plus every pi n, right? Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, and so on. Those will all give you 0, right? If you plug in those values. Everybody good with that, right? That's when cosine is 0, pi over 2, and every increment of pi after that. So that would tell us that t must be multiplied by 6, which will give me 6 pi over 2, which is 3 pi, plus 6 pi n, all divided by pi, or 3 plus 6 n. And so then you'll just plug in values of just plug in values of n. So integer values, n equals 0 gives you 3, n equals 1 gives you 9, n equals 2 gives you 15, which tells you that you are no longer in that interval that you were looking at. And so you would find that there are only 2 places where it could possibly change signs. Put on 0, 3, 9, and 12. Do a sign chart for v of t to make sure you know when it's moving left. So if you plug in something less than 3 but greater than 0. So for example, well, we could plug in 0. So the cosine of 0 is 1, which is positive. Plug in something between 3 and 9, like 6, would give me cosine of pi, and cosine of pi is negative. And then something like 12 gives me cosine of 2 pi, which is again positive. So you would say it's moving left on the interval 3 to 9, or t is greater than 3, less than 9, or you could write it out in words, between t equals 3 and t equals 9. And so that would work 1 point. 1 point if you just set the function v of t equal to 0, and 1 point for getting the right answer. Any questions on part A there?
No.
All right. Part B wants us to write but not evaluate an expression that gives the total distance traveled. So remember, total distance is the integral of speed, which is the absolute value of velocity. So if we're going from 0 to 6, part B should just be an integral from 0 to 6. That does not look like a 0. That looks like a 6. There we go. The integral from 0. Oh, that looks more like a 0 now. I can really write 0 to 6. That's so much better. Of the absolute value of v of t dt. Good enough. 1 point. Just 1 point for part C. Good or no?
Good.
All right, part C, find the acceleration of the particle at time t, and then we have to determine if the speed is increasing, decreasing, or neither at t equals 4. So first off, acceleration at t ought to be the derivative of velocity at t. And what was our velocity? It was cosine pi over 6t. So using the chain rule to differentiate that, we ought to get negative 6 over pi sine pi over 6t. Why did I put a 6 over pi? We're not integrating. We're taking derivatives. Negative pi over 6. That was stupid of me. Sorry. Negative pi over 6 sine pi over 6t. I should do my derivatives correctly. So that's worth, I don't know, 1 point probably for getting the acceleration. Yeah, 1 point for getting the acceleration. And then they want us to find if it has the speed is increasing at t equals 4. So we'll look for a of 4, which is negative pi over 6 sine of 4 pi over 6, so 2 pi over 3. And the sine of 2 pi over 3 is a positive value, so this is a negative value. And then we'll look for v of 4, which was cosine of 2 pi over 3. And the cosine of 2 pi over 3, that's a second quadrant angle. And in the second quadrant, cosine is negative. So since they both have the same sign, they're both less than 0. The speed is increasing. Any questions there on part C?
How many points was that?
So like I said, 1 point for the acceleration up there, 2 points for the rest of this. Speed is increasing and the reasoning for it. And the reasoning for it includes all of this. I mean, showing a of 4 is negative, showing v of 4 is negative, and then same sign, speed increasing. All right, part D asked us to find the position of the particle at t equals 4. So we're looking for position. So that doesn't involve speed, that involves velocity. So we need to integrate the cosine of pi over 6. So let's see, I need a page here. We're going to say part D, we're going to say the integral from 0 to, oh no, I forgot what value we're looking for that. 4? Yeah, 0 to 4. Cosine pi over 6t dt. And then we have to add to that our initial condition. So that t equals 0, x was negative 2, position was negative 2, so negative 2 plus that integral. Everybody good with that so far? So we end up with, now when I integrate this, I should get 6 over pi sine pi over 6t when you do the u substitution on that. And 0 to 4. And you'll plug in your values. Over pi sine 2 pi over 3 minus 6 over pi sine, that's a thing, 0. 6 over pi sine 0 is just 0. The sine of 2 pi over 3 is root 3 over 2. So we got negative 2 plus 6 root 3 over 2 pi, or negative 2 plus 3 root 3 over pi. Good or no? 1 point for the right antiderivative. 1 point for remembering to use the initial condition at some point in it, and 1 point for the correct final answer. Any other questions on that one?
For those people who are doing it online,
Mm-hmm.
are they gonna like show all of this work just by typing it out, or are they like uploading pictures, or like? Is
Well,
it just
that's a good,
answering?
there will be no picture uploading on the digital exam. There will be some like typing in through their keyboard of things, but what they have said is that it will be more theoretical, sort of like where you will just be like describing what to do kind of stuff for different types of problems. So I don't know if that's better, maybe better or worse for some people. There's a whole thing about it on, I thought I had talked about that when I had that little meeting, but maybe I didn't. Anyway, there's a whole, they have a little like paragraph about it on the College Board website. If you go into like if you just go into College Board and search for like digital AP calculus AB test or something, they have like a little paragraph in there that sort of explains the difference between the free response questions between the paper and the digital tests. And they haven't even released anything that's supposed to like model what the digital ones are looking like yet. They said early April. So, I mean, which would still give you 2 months because the digital one is early June, but still be kind of nice to have them now. Does that answer your question or no?
Yeah.
Okay. All right. That's not the right one. Is this the one I asked you guys to do? About Ben writing his unicycle?
Yeah.
Okay. All right. So we got Ben. He's on his unicycle, blah, blah, blah. We've got a nice little chart that gives us his position on the track. It also gives us his velocity at any of those given times, 0, 10, and 40, and 60. And first thing we're going to do is use the data in the table to approximate his acceleration at t equals 5. And so in order to do that, all we have to do is, I'll put this over here. All we have to do is do the average rate of change of the velocity from 10 or from 0 to 10. So we'll do v of 10 minus v of 0 over 10 minus 0, which ought to be 0.3 over 10, which ought to be 0.03. And it says indicate units of measure. So acceleration, if this was meters per second, and t is measured in seconds, this ought to be meters per second squared. Everybody good there with part A?
Yeah.
Cool. All right, part B says using correct units, interpret the meaning of the integral from 0 to 60 of the absolute value of v of t. So we would just say, since this is the absolute value of v, that's the speed, and the integral of speed is the total distance traveled. So this is total distance Ben travels in t equals 0 to t equals 60. Oh, sorry, I forgot. This was worth 1 point. And then the meaning of the integral here is 1 point. And then they want you to use a left Riemann sum to approximate that value. So using a left rectangular approximation, our first interval is 10 units long and has a height of 2. So that'll be 10 times 2. Second interval is 30 units long and is 2.3. Next interval is 20 units long and has a height of 2.5. So you just add all of those things together, and that should come out to be, let's see, what is this? This is should be 139 meters. And having the right answer there was worth 1 point as well. Good or no?
Good.
Wonderful. All right. Part C says for 40 to 60, must there be a time when his velocity is 2? And so we can look at it and it doesn't look like there has to be. Just, I mean, you know, if we go from 2.5 to 4.6 in terms of velocity, the intermediate value theorem wouldn't tell me that I had to go to 2 between those, but it doesn't mean that I couldn't have gone to 2 between those. I could have slowed down to 2 meters per second and then sped back up. And we don't know what's really happening between 40 and 60. So the intermediate value theorem can't tell us anything about it. But the mean value theorem could, because the mean value theorem says that if the average rate of change of the position there, of the function b of t, was equal to 2 on that interval, then that would tell us that the instantaneous rate of change, or the velocity, would have to equal 2 somewhere on that interval. So if we look at b of 60 minus b of 40 over 60 minus 40, we want to know, does that equal 2? If it does equal 2, then it tells us that he must have been going 2 meters per second sometime on that interval. And so what was b of 60? It was 49. So 49 minus 9 over 20 is definitely 2. So yes, by the mean value theorem, since b of t is continuous and differentiable, and the average rate of change is 2, then the instantaneous rate of change must be 2 somewhere on that interval. And so that was worth 2 points. One for setting up this b of 60 minus b of 40 over 60 minus 40, and one for the conclusion there. Good or no?
It's good.
Cool. All right, part D. Part D is a little bit different than what we've been dealing with previously. We got a light that is directly above the western end of the track, and he rides so that at time t, the distance between him and the light is that equation. We want to know at what rate is the distance between Ben and the light changing at t equals 40. So we are effectively trying to find a rate of change of a distance, right, which is a related rate question. And so we've got L of t squared. So when we take the derivative of this, what should we get? We should get 2L of t, that's not an L, 2L of t, that's the derivative of L of t squared. But then since we're doing it with respect to t, times L prime of t, and then that should equal 12 squared is 144, the square root of 144, the derivative of 144 is 0, so we can ignore that. And b of t squared, when we take that derivative, should be 2b of t times b prime of t. And so then we're just going to have to plug in all of our values for all these other things to figure out what L prime of 40 is. It was 40, right? Yeah, L prime of 40. So L prime of 40 ought to be 2 times b of 40, which was 9, times b prime of 40, which was 2.5, divided by 2 times L of 40, and L of 40 ought to be, we can find that from here. So L of 40 ought to be, I don't have the equation written there. Cool. L of 40 ought to be the square root of 144 plus 81. And 144 plus 81 is 225. So that ought to be 15. So we'll put 15 down here, cancel out our 2's. And let's see, what do we get here if we divide all that out? Um, 9/15 is 3/5. That ought to be 7.5 over 5, which we could rewrite as 3/2. That might be nicer. 3/2 meters per second would be the rate that that's changing. Good or no?
If I like, instead of doing the derivatives when like it's equal to L squared, if I square rooted the expression and did the derivative that way, would that work?
Yep, you should get the same exact thing.
Okay, cool, thank you.
Yep. And this was worth 3 points. 1 for the right derivative stuff. 1 if you were able to figure out what B prime was, so knowing that that was V of t, and 1 for the right answer here. And so you'll note that that only adds up to 1, 2, 3, 4, 5, 6, 7, 8 points for that problem. But the 9th point they gave, they said if you had the right units in either A or B, that was a 9th point. Good or no?
What? How many points was the last one worth?
It was worth 3.
Okay.
1 for the expression, 1 for getting the right value for B prime, and 1 for the final answer. All right. Let's see, this is probably the last one we have time for today. So we've got for 0 to 6, we've got a particle moving along the x-axis. So given we don't have an equation for the position, but we have one for the velocity. We're also given one for the acceleration, and we're also given an initial position. These should be getting pretty easy, I hope. These calculator ones, is the speed of the particle increasing or decreasing at 5.5? Well, to figure that out, you need to find velocity at 5.5. And you need to find acceleration at 5.5, which is V. Well, they give us acceleration, so we don't even need to use V prime. So you just plug in 5.5 to both of those. You'd find that the velocity is negative 0.45337, less than 0. And the acceleration you'd find is also negative 1.35851, which is also less than 0. And so same sign, speed increasing, and you'd want to write that the speed is increasing because they have the same sign. And 2 points for all of the work. You got to have the correct answer with the correct reasoning. Good or no?
Good.
All right, exciting. Part B asks us to find the average velocity on 0 to 6. So the average velocity is just the average of this continuous velocity function. So 1 over 6 minus 0 times the integral from 0 to 6 of v of t dt. Since you've got a calculator, you just plug it all in, and that should come out to be 1.949. 1 point for the correct integral setup, regardless of whether you got the 1 over 6 in front. 1 point for the final answer, which you wouldn't have got that without having the 1 over 6. Good there with B?
Yeah.
All right, part C, find the total distance traveled by the particle. total distance traveled is just, once again, the integral of the speed, which is the integral of the absolute value of velocity. So should be pretty straightforward. 1 point for that setup, 1 point for getting the correct answer, which was 12.573. Everybody good there?
Yep.
All right. And then part D. So for part D, it says the particle changes direction exactly once on the interval 0 to 6. Find the position of the particle at that time. So first off, we got to find that time. And so to find when the particle changes direction, we got to set v of t equal to 0, which gives you a t value. When you graph v of t and you look for its x-intercept, it gives you 5.19552. And then you would need to indicate that v of t changes from, and if you're looking at the graph, from positive to negative at 5.19552. So that is worth 1 point. And then to find the position of the particle, you need to then integrate from 0 to, let's see, is it 0? What was our initial condition they gave us? Yeah, they gave us an initial condition that at t equals 0, the position was 2. So it would be 2 plus the integral from 0 to 5.19552 of v of t. And 1 point for setting that integral up correctly, and 1 point for the final answer, which came out to be 14.134. Good or no?